I'm not sure if people are aware of all of this, and it was definitely a unearthing of a large ancient ruin, if you will, with regards to understanding the history of astronomy and why things are the way they are. Um, for this talk, I'll go ahead and review some things Adam had talked to me about, and I think okay, I was thinking about last night and I thought to myself, Jeff, make sure that you let people know the purposes of this. And the purpose of this theory is to give us a new worldview uh, of the stars, of the earth, of life itself. And that's it. My purposes aren't to argue with people, it isn't to cause people to be upset or mayhem and, to get people fired from their job. Even though, in the past I was very angry and, I probably said a lot of stupid things, but I didn't really mean any of that. It was just frustrating dealing with people who were obstinate at times. And I just learned just to brush it off and keep focused and realize that this is a pretty big thing. It's much bigger than me. And if people can realize that it's much bigger than me, they can take it upon themselves and work on it themselves without me needing to be there at all, to be honest with you, because this isn't just about me. This is about all of us. That being said, he had mentioned the patterns with the moons and the sizes of the objects. Jupiter and Saturn being about the same size, Neptune and Uranus being about the same size. And then the patterns of the moons, how they were increasing in size as they moved away from the host object. That is very interesting. I actually never even noticed any of that, but it did bring up an idea that I had reviewed earlier, and that is statistics. If we're going to find meaningful patterns inside of the stars, we have to make sure not to fall into the same trap the establishment fell into. Because remember, before the 1980s, the solar system was the entire sample that we had, the only sample of the only solar system that we knew of for the past 2,000 plus years. So a lot of what you see in the solar system, we're like, okay, in the solar system, that's how all the star systems are supposed to be, and that just simply isn't true. We had a sample size of 1 out of 200 billion, and this specific example is essentially zero data. Even with a sample size of 10,000, it would still be, essentially zero data. But it's a hell of a lot more than 1, and that's the solar system. So that being said, Adam, just make sure that when you look for patterns like that, I know you're going to find patterns that I didn't see before, which you already have. Take that mindset and apply it to these specific ideas here. Okay, so we have objects near the same plane. Make sure you look for that and see if the objects are not on the same plane. So they'll orbit around at like 90 degrees, and then one will be, at a different inclination. The orbital inclinations of the objects is extremely important. Pay attention to that. There might be patterns there as well. I'm pretty sure Jupiter has some weird moons that have different orbital inclinations. Also look at the center, the singular mass into the entire system. Make sure you look for patterns in that. In some systems, star systems, you'll have 2 masses in the center, 2 very large masses, sun-like and red dwarf-like in the center. And some of them have even 4 masses, like there's a quad system with 4 bright shining stars, and that's absolutely incredible. I can't even imagine what that would be like. And then you have objects that orbit in the same direction. A lot of the solar system bodies orbit the same direction. And then you have retrograde orbits, where you have the star spinning in one direction, and then you have the older star spinning in the other direction as it orbits. Now, these weren't predicted by the establishment. They thought they all rotate in the same direction, but we all know better. Also, check out close-in gas-type stars and check out how the really far ones, because there's patterns in how close and how far away they orbit. And then look at, you know, their orbits themselves, if they're circular or if they're elliptical. There's a lot to it, and just look at all of that as a whole, and get as many data points as you can, get as many samples as you can, get as much information as you can. Don't be like the dogmatists where they say, well, everything's supposed to be like the solar system, and then they're shocked as to all the exoplanet systems were all different, and it's bad news on their part. As well, you had mentioned how I would figure out how old these objects are. Now, I know the ages probably aren't correct. I know that. There's no way I can figure out their ages. I guess the purpose of it was to give people an alternative mindset altogether, because the alternative mindset didn't even exist. Remember, everybody in astronomy and astrophysics, they're trained and told that all the objects in the solar system are 4.5 billion years old. So naturally, the concept of Jupiter being 350 to 400 million years old, to Earth being 10 billion, to the sun being around 65 million years old, that just, what? You know, that concept doesn't even exist to them in their minds. And just to get something like that out there is just a completely different way of looking at the solar system. And that being said, I think I had some way of determining the ages by the rate of differentiation in the size of the iron cores of the oldest stars. I'll have to find that paper and talk about that. I can't address it for this talk. But the last thing I want to address here is the homogeneous nature of the sun, and this is why I believe it's a very young star. It isn't just me, okay? I'm just making this stuff up out of the blue. Homogeneous meaning it's the same throughout, homogeneous throughout. That's young stars, and then old stars are heterogeneous and they have layers. And of course, the specific layers themselves can be much more homogeneous, but they're layered like onions, you know, like like Shrek, you know, it has layers. And that being said, young stars can't have nuclear cores if they form cores as they age. That's basically my reasoning. But I did not know this, okay? I did not have any idea that this existed. Remember, I was born in 1984. I'm told everything about the world around me when I'm a child, and then I grow up and I'm, oh crap, you know, here I am, 34 years old, finally finding all this out. Of course, I found this specific thing when I was about 28, 29, so about 5-6 years ago. I just don't discuss it that much. Of course, I'll link it to the bottom. But there were researchers that determined that the sun is homogeneous, and that being said, that the sun is probably young. I'll read this out to you guys and then explain what it means. Davies claims that if the sun had a large and massive core, as predicted by the standard models of solar structure and evolution, then this core would have a substantial effect on global oscillations. He explains that such a large core would mean that the sun's global oscillations would range up to a maximum fundamental radial mode of oscillation of around 1 hour. He then adds that fundamental oscillations greater than 1 hour would involve such enormous amounts of energy that they would result in the complete disruption of any large core that might be present in the sun. In contrast, however, he states, for a very young, homogeneous star that has not yet developed a large central core, its spectrum of global oscillations have been calculated to be as high as 167 minutes. In fact, he claims that this is a key distinguishing feature of a young, homogeneous star. Here's a cutaway of what the sun probably looks like. See here. And it has more there. I don't want to go over too much, but basically these ideas were independently verified by two independent researchers from across the earth. Brooks and others in 1976, and Severny and others in 1976 as well. And papers by J. Christensen Dalsgaard and D.O. Gogh in 1976 as well. He quotes them as saying that in order to account for the 2-hour, 40-minute observation, it is evident that a very drastic change in the solar model would be necessary, and it is unlikely that any such model can be found. Basically, what they're saying is a global harmonic radial oscillation is, say you have a big bowl of jello, it's spherical ball jello. When you shake one side, the whole jello shakes and it goes all the way through the other side of the jello and then all the way back. It's radial through the center of the object. Now, if it had a very long radial oscillation, it means the oscillation is going all the way to the center and all the way to the other side. Or all the way to through the center to the other side and all the way back. It's the oscillation. I'm pretty sure this is what it means. Could be wrong. But that means if the radial oscillations are long, then there's no core there. If it only had short oscillations, it would be bouncing off the core and then coming back. And that's what they're saying. They're saying they have long oscillations. It's a giant ball of plasmatic jello, if you will. And that's basically it. And then it differentiates as it cools and dies. But yeah, I'll link this stuff to the bottom. I don't want to make this video too long. I don't like really, really long videos. But 1976, you guys. They buried this stuff long, long ago. Later.